Hi, I want to look at a couple of old meters today. We've all seen the modern digital meters, but if we want to look at some old analog meters, particularly these old vintage types. Analog meters have been around a lot longer. This is a little moving coil meter. If I dismantle the moving coil meter, we can see inside there is a little needle attached to a coil which moves around a magnet, and that obviously can be displaced by a small current going around the coil in proportion to the movement. But even these around are fairly more recent. Prior to that, more commonly is this type of meter. This is a moving iron meter. If I take this out, a slightly simpler looking meter. This is for amps, and there's quite a large coil in there, and it's actually a piece of iron that moves around inside this. The nice thing about these is they can actually measure AC and DC. The moving coil meter, you need to rectify the voltage, otherwise it won't respond to an AC signal, whereas these do. These have been around a long time, and there are some very early examples. These nice old meters made in a cast iron casing, are rather nice. This type, if we take it apart, you can see this is also a moving iron meter. With the actual scale removed from this meter, we can see the components in it. We have a large coil which always takes the current running round this bobbin part, and we have a damper in here to dampen the movement, and a couple of stays for the needle. We also have a position, kind of zeroing position there. So we'll dismantle this further. So if I take this out, we can see in here we have a little vane that's basically to dampen the needle's movement. It's actually seems to be jamming in something at the moment, and this is just to stop sudden erratic movements. You can still further dismantle this. So this part comes out, and in here, this is just the coil, or the current coil, and we have our moving iron piece inside here. So taking this apart carefully, you can see this is our moving iron. This is a piece of iron that becomes magnetic in this field inside this coil. The nice thing with this, you have a very large coil in here for the current, which means you don't really need a shunt as you would on a different smaller meter, and it influences the magnetic field on this moving iron. So damping vane, a return hairspring, and our moving iron part to the meter, and our pointer. So quite simple and yet quite effective. You can see the damper working in this situation. The damper will also protect against vibration from the frequency that's induced in the iron as well, to stop it just buzzing and giving you a foggy image. And then just to completely seal this up into its little chamber, the little screws go in as well. Now with the end stops in place and the damper back in, we can put this back into its housing and return the display to the front. One other meter I've come across that's worth having a look at, another current meter, is this one. This one doesn't use moving iron. This one has a very clever arrangement being a thermal pickup. So there's a bimetal spring on these, and it's the temperature on this coil here proportional to the current that actually produces the movement in this needle. This one's a reset needle as well, which can be driven by that to position. Interestingly, there are two bimetal springs, one attached to that are close to this heating coil, the other in ambient. These obviously are to offset the ambient temperature. If both coils heat up proportionally, then there's no net movement. If the coil on the spring and the coil here heat up, then it will indicate a current. So it's very slow acting, so that's the problem with it. So I can demonstrate it with a hot air gun. So you can see with the hot air blowing over the single coil, we have an output displayed in current. If I heat the other coil, the two coils equally, the needle won't move. So that's quite a clever use, or clever type of meter, I think. Let's try. Finally, just wanted to look at this. This is a kilowatt hour meter. I did a kilowatt hour meter before for a three-phase system. This is also a three-phase kilowatt hour meter. If we look inside it, this one doesn't use an external transformer. This is just directly connected with very large current coils. There are 3 large current coils on this meter, and one tucked at the back there. And the interesting thing, this is obviously a more of a kind of digital readout, but it's an analog meter. And if we look at inside again, there are 3 coils for driving voltage and current for our 3-phase meter, and our disc is visible here rotating in the direction of with the current phase. Now, there are adjustments for current settings on this meter as well. The interesting thing in this meter is there is a mechanism that if the disc rotates in reverse, it will lock.